Okay.
Let me get back over there. Sorry, I was. Yeah. So number 3, I have the third one down.
That's what
That's what I put too.
Okay.
And then number 4, that's the third one down too?
Yeah.
Yeah, that's what I have.
Yeah.
And 5 would be the first one.
Yeah, that's what I have. Damn it. Are you stuck?
I think it would be the first one. When I was reading the book, it kind of confused me because it said like if linear regression is appropriate, then it'll show no patterns and it'll just be like random. Was it? But like none of the answers. There was a chart. Like it makes sense for it to be that way, but the way that the book put it just kind of.
Yeah.
What did you?
In the chart, just like there was it said like if linear regression is appropriate, then the plot will show no patterns and it'll just be random. But then in
Yeah.
like linear relationship, and then it'll have like the hot dog shape. So that would mean that it's normally.
Yeah, but that's normally distributed, right?
Gotcha.
That's what I figured, because watching the videos and stuff, he went over how, on the linear side or whatever, that's going to have the hot dog shape, but if you put it into the scatter plot, then it's going to be scattered. There shouldn't be any particular pattern to it.
Gotcha.
So that'll support the linear regression when there's no particular pattern. But if there is a pattern like the megaphone or some other type of pattern in the scatter plot, then that doesn't support the linear regression.
Okay. Cool.
That's how I understood it anyways.
Yeah. Okay, let me open this file up.
And then number 6, I would say that the residuals form a linear pattern because they're not all negative. And I don't remember. Oh, go ahead.
Be the first one, but
the first one. So where do you find? I think it's 46.
Because I'm just looking at like the shape.
You're looking at the shape to say that
the document. Sorry, it went down. I'm just trying to pull it back.
that the residuals are between -40 and 25.
Yeah, I thought.
Okay.
But
Huh?
I thought they were.
Well, like on 17, there's a that's 0.46.
Okay.
Okay, so which are the on the actual table under T linear regression? Which ones are well, the residuals are just in that far right hand column. There's no other place that they're put, correct?
Did you guys already copy this over?
No,
I did.
haven't.
I
I'm still
copied it.
working on it.
Oh, okay. I was like,
I copied it over while I was waiting for you guys to start.
Yeah, I did before we started a group meeting.
gotcha. Okay, I'm still copying it over, but you have the explanatory variable X as like the confidence one, right? Oh wait.
Yeah, that's what I put it as.
Okay.
Is that what I did? Oh, I put the score. Sorry, I put the score in the first one in the explanatory variable, but we're supposed to put it in the.
So the score one should be
The scores.
the second one, and the confidence
Score should be under Y.
Yeah.
Okay, that's probably part of my issue. I don't remember looking to see specifically what it said.
Just making sure I had it right.
Okay.
Yeah, I think you might be right. It might be B. Because it wouldn't be the third one.
And I was trying to figure out where else besides that whole column that we would look to find where, because I can't remember, where in the Excel document, where else in the Excel document you would look to find what the range of the residuals are.
Yeah.
So that's why I was figuring that it was the second one.
Do you guys have it up yet?
Yeah, I'm just looking at it. Would we have to make, is the scatter plot that it gives us, is that the scatter plot for X and Y, or is that the scatter plot for the residuals, or do we have to make a new one?
I just left that in there from part of the chart or the scatter plot that we did for while we were going through the lesson. I just left the scatter plot in there. I haven't changed it. So it's for it's the explanatory variable and the residuals combined.
Okay.
In the scatter plot. That's the way I have it anyways. If I'm wrong, then somebody don't hesitate to tell me.
No, I think that's how it should be. So the second one then for number 6?
Yeah, that's what I have.
Yeah, I think that's right.
Based on the QQ plot, what can you say about these?
But they're fairly normal. Or am I wrong?
No, entirely.
Oh, this one doesn't. Oh, that's just nice. What do they do?
How do we see the QQ plot again?
Here we go. Now the QQ plot, isn't that the one that's already in there? The series 1 plot? The first?
I think it's a different one.
Yeah, because it has to all be from like smallest to largest. For the QQ plot, I thought.
Oh, where do we?
That's
I'm
what
trying
I
to
remember.
copy and paste the data, but it's not working.
And which one is the QQ plot in?
Is that in the?
It's in the quantitative descriptive.
Yeah, that one.
Let me look.
That's what I've been trying to copy and paste into. I just finally got the data in there.
Oh, there we go. I see the QQ
Yeah,
plot.
I'm doing it right now.
Okay, and so we're just doing, are we just doing the residuals there? What is it? What's the question? Okay, so yeah, we are. We're just doing the residuals for the QQ.
So then you have to sort.
Seriously, mine's like going overboard when it's.
Mine is too. I have like so many tabs open. It's like.
Yeah.
Mine's being completely spastic.
So we just do the residuals for our QQ plot.
Yeah.
Yeah,
Okay.
I'd say it looks fairly normal. What I'm getting, at least.
What on earth? Mine is like totally not copying and pasting over.
I would
Yeah,
say
mine was.
Mine's like being really slow too. So strange.
Yeah, mine's taking forever and doesn't like me.
Yeah, mine either. Like my Excel spreadsheet froze up.
Now we're supposed to sort it by ascending, right? Or is it
From
descending?
lowest to highest.
Oh, let me
Oh my heavens.
sort it.
So mine like pretty much follows a straight line the whole way through.
Okay, well,
Yeah, mine too.
I'm gonna have to go off of what you guys, because I might end up having to restart my computer. I don't know. Like my entire
Mhm.
Excel. There we go. It shut down completely.
Oh
It
no.
closed out on all. I mean, it's not responding.
Yeah, I think it would be the fairly normal for 7 though.
Yeah.
The original
Mine's
grid,
not sorted
okay.
right at all.
Yeah.
Okay.
Scatter plot is it is incapable to apply sections are satisfied.
I'm not gonna save changes right now. Oh my heavens, this is horrible.
I think it would be the first 3.
Yeah, I'm just going through. So it's definitely the first one because it's like that hot dog shape.
Mm-hmm.
The variance of the error term is constant for all values of x. So that one would be true because we don't have any outliers really, right?
Yeah.
Yeah,
And
I
then-
didn't see any outliers.
The residuals are normally distributed because they form a straight line or?
Yeah.
Okay.
Yeah, they do.
The x values are measured without error.
Okay.
Well, that's one that we have to just rely on the fact that they did it correctly.
So which ones? Sorry, I'm like trying to open my Excel again so I can get caught up. So
We just said the first 3 are right.
the
Yeah.
first 3, so there's a linear, the variance of the error, and the residuals are normally. So we have all those 4 checked, or all those 3 checked.
Yeah.
Yeah.
Yeah. And then the fourth one, the x values are measured without error. What does that mean?
I don't think it is. I don't know.
I have the chart copied over and it says cannot be checked directly. X's should be measured accurately and precisely. So it has to be
Okay.
the person counting them has to measure them correctly.
So
And
we
so we
can't.
can't.
that.
And so they said, I think in the textbook it said to just assume, or no, in the chart it says, in other words, the X's can be considered as known constants.
Okay.
Oh yeah.
I think for some reason we're supposed to just assume that they've been measured without error.
And
Okay.
then we can't. The chart says too that we can't check the last one either.
Yeah.
So just the first 3.
And so are we marking the last 2 or no?
Just the,
No, just the first.
no,
Okay.
Okay. And what is B1? The estimate
Oh goodness, I have to copy.
is slow.
I'm behind, guys. Sorry. Now that I had to reopen my stuff.
You're good.
Is that 12.695?
Yeah.
So number 9 is 12.695.
Mm-hmm.
Okay.
Yeah.
I'm still working on getting everything transferred back over.
That's fine.
What a pain. Are you guys glad that we only have next week left?
Yes. So happy.
we getting
I'm like, I have a week off.
So
What am I
exciting.
gonna do?
Would the lower confidence interval be 10.674?
Yes.
That's what I got.
My thing is you have to remember that it's the confidence interval is for B1 or slope.
Yeah.
I must have put them backwards again.
Yeah. The upper is
Oh,
14.715, right?
None.
yeah.
Look,
Yes.
I did. that when you're in a hurry. I'm gonna have to ask you guys to repeat it here in just a second.
You're good.
If you don't mind.
Yeah, I understand. It's like seven.
One
Just
of
like
those days.
Where does it tell us the p-value again? Written down.
10.674.
In the unstandardized coefficients.
So for 10, you guys got 10.674, correct?
Yeah.
And then the upper bound, you got 14.715?
Yeah.
Okay.
Sorry, where is the p-value? Under
Under unstandardized coefficients. So take the slope B1 and read it all the way across to the right.
I see it now. Okay.
It would be 0.000.
Yeah.
Okay, so what did I do? The slope B1, I know we're still using the math. And you guys have the p-value is what?
Well, the p-value is like 3.31266
Okay.
e to the negative 24, which is, when you put it in the way she wants us to, it would be rounded to, or would be translated as 0.000. So essentially 0.
So we would, the third one for number 12, reject the null because the p-value is less than a.
Yeah.
Yeah.
Okay, so I have to remember how to get the p-value then from that.
I think it's, what is it? Oh, I can't remember what it is. But you basically have to convert the number that's in the chart. But usually if it's one of those numbers, it's probably just 0 with decimal point and then 3 other zeros.
Okay.
Yeah, it's like,
it's probably going to mess me up later trying to remember how to convert that p-value so we know.
if it's e minus 24 or like e negative 24, it means that there are 24 zeros before that number.
Yeah.
So it'd be 0.
I can never remember.
4 zeros and then 3.3 mapping.
Okay. I think I'm still confused, but that's okay. There's nothing new.
That's what it is. Scientific notation. So that's scientific notation, and so you have to convert scientific notation to standard decimal.
Gotcha. Okay, so moving on, sorry.
For a hypothesis test for beta 1 slope, if you reject the null, what does that mean? There is sufficient evidence. The last one?
Hold on. We have sufficient evidence. Yeah, if we reject the null, we have sufficient evidence to conclude that the slope of the regression line is not 0.
Yeah,
we rejected
the 0 for me. Oh, but yeah.
Yeah.
It was just the 0 part threw me off, but yeah, I think that's right. The last one.
Yeah.
Okay.
Next one would. Let's,
Boy, copy data.
Is our head length or the body length the dependent variable?
The head length is not the dependent. Because it's based on, the body length is based off of the head length.
Right. Okay.
So are we putting body length or head length?
Head length, I think.
Head length.
Yeah,
Because
head length in the
body length
explanatory.
Response variable, right?
Then what?
Because the body length would be like the response variable.
Yeah.
Yes,
That's the only one I can remember because I specifically remember that the body length is based upon whatever the head length is.
Yeah.
That's what, it just makes it easier for me to remember because I can't even remember how we went off of the other one.
you know, all this data copying.
We just need to be able to hit a button and I'll be there, right? It'd be so much easier. Okay.
I need a faster computer, apparently.
Well, the dependent is the head length. Sorry, I wasn't even paying attention. I was just copying and pasting.
Very good. Wait, so for this one, we'd have to switch up too?
I don't think so,
No?
right? Because the X, or the explanatory, is the dependent, right?
Mm-hmm.
Okay, I have to look at that again, but you're probably right. I'm just always like,
Me.
am I putting this in
Let
the
me go
right?
back in my notes. I know I wrote it down somewhere.
So, okay, yeah, we're good.
Okay, so it was the first one, head length. And then determine the margin of error.
Working on data. The computer just started running really slow.
And this one, like, interval for so would we do 8.103 minus 7.218 divided by 2?
Divided by 2.
Yeah, I think so.
Yeah.
I know I'm waiting on my computer, but yeah, the margin of error is this calculated the same, the highest minus the lowest divided by 2.
I
Would
got,
be 0.443
yeah,
rounded.
yeah,
What was it? 0.44.
443.
And then the lower bound
Because
is
I took the homework quiz and that worked for that question on the homework quiz.
7.218 for the lower bound.
What was
yeah,
it?
7.218.
7
Yeah.
And then 8.103 for the upper bound.
Yeah.
You just put 0.218 for the lower bound, right?
7.218.
7.218
Yeah,
and
And
then
then-
8 point.
10.
103.
Okay. Sorry, I'm still waiting on my computer spreadsheet.
I think it'd be the second
That's what I was.
Yeah.
one.
hmm
Oh, no, because it's a confidence interval. So we need to state it as we are 95% confident.
Yeah,
Yeah.
the first one.
So it's probably the first
Right.
one.
Probably
That's what
the
gets me because I'm like, oh, there's a 95% chance, which makes sense. But when we're talking confidence interval, that's
Yeah.
that's why I've been able to keep it apart. That when we state it in layman's terms, whatever we have to say, we're 95% confident.
Yeah.
Okay.
Okay, I'm gonna submit it.
Okay.
We got 16 out of 18. So
So which ones did we miss?
number 14 and number 6.
Number 14, we put the head length, right?
Yeah. I thought that was
I thought that was right though. For 14, that's
Let me
weird.
look. Hold on.
Because if
let me-
14's wrong, how did we get the rest of it right?
That's what I'm wondering. Yeah.
X is the independent variable or the explanatory variable.
Hmm. That makes sense.
Y is the dependent variable or the response variable.
Hmm.
So X is the independent. So that would
And
mean
Y is the dependent.
so body length would be the dependent.
So we still put them in right. We just
got it mixed.
Oh, I see. So if you look at it, dependent, it's dependent on something else. So like the body length is dependent on the head
upon
length.
the head length. Yeah.
So that.
So that makes sense. Yeah. I get it mixed up. Like on one of the questions for last week's quiz, homework quiz, I literally had to take, because I wrote down some notes specifically off of the videos for this particular one, because all of them have talked about the head length. The body length depends upon the head length. And I literally had to write down the problem and then replace some of the words in the problem for the crocodiles with the particular problem that I was working on for the homework quiz.
Hmm.
So I understood it.
So the body length is dependent on the head length. So the body length is the
Dependent variable. Mm-hmm.
dependent.
Yep, because the body length, the
Oh.
length of the body is going to depend upon what size the head is. So if the head is bigger, the body is predicted to be bigger.
I always just look at it as like Y is what we're trying to predict. But that's confusing to me. Darn. Oh
I guess
man.
another way to look at the Y is the response variable. On the chart, a response would be a response towards something else. So like if someone does something to you, you respond.
Yeah.
Yeah.
And so it would be dependent on someone else doing something for you to respond.
Sorry.
So